Thanks to be here. I'm glad to be here too, to speak about Twig compilation. So let's go. I'm Nicolas Perussel, aka Mamoot. I'm a PHP technologist since 20 years, okay? And I'm actually CTO, PHP CTO at Equino. I'm like painting Warhammer. Maybe I think I'm not the alone man here to make this. I'm a big fan of Mario. And because we are in Belgium, I need to say I really like Gaston Lagaffe and the special character, La Mouette Rieuse. I don't know if you, maybe I'm not the only one too. So let's go. Just let me explain what is the act of compiling something. In computer science, compilation is a simple process to transform one language to another language. In fact, it can be complicated to make these things, but if we need to specialize this definition, it's already a good thing to know that we need to convert a high-low-level language to a high-level language, so to a low-level language, sorry. Here are some examples. We have C, which is compiled to assembly. We have TypeScript, which is compiled to JavaScript. It's not really a compilation, it's a transpilation, but it's a subset of the compilation theory. It's not very important to know the difference between this type of compilation. And the last example is Twig. It's compiled to PHP. So, why it's very important to study the compilation of Twig? Here are written on the screen some good arguments, but for me, the better arguments I can say is to have a better understanding of the internals of our libraries that we use day to day, to be a better developer. Because if we have a good knowledge on the internals, we can have maybe better idea to produce our code and to enhance our feature or enhance our coding. So I like Street Fighter too. So let's go, let's fight with the compiling theory. Here is a very simple example, okay? It's a minimal code to bootstrap Twig. It's not so complicated. We need to have a loader to load some files. We need to have an environment, Twig environment, very important, to bootstrap Twig, in fact. After, we need to load some template, and we need to render it. This is not so complicated. And at the end, at the bottom of the screen, you have a very simple Twig template. So if is in Belgium, I display hello name from the Drupal Dev Days Leuven, else hello, only the name. Very simple, I think. So from this example, we will study the compilation pipeline process. So there is a lot of components that will be introduced during this talk. It's not a deep dive in each component, it's just a huge overview to give you some vocabulary or some insight about how it's working under the hood. We have the tokenization phase and the lexer phase. We will study this after. We have the parser, semantic analyzer, a phase of optimization, and after, the code generation. Okay? So, sometime I said AST. It's difficult for me to say that, so sometimes you will hear AST. If you said this, compile it to AST. Okay? Let's go. Let me introduce the first stage, the lexer. The lexer, it's a first step to the compilation process. And here, it's a very simple example on how to make this with Twig in PHP. The first things to do is to decompose the load method and the random method that was in the previous slides. And the first things to create is to call the tokenize method on the Twig environment to produce a token stream. There is a lot of keywords here. Let's deep dive inside. If we need to have just an overview of what is tokenize, it's a method to produce some token Okay, donc we will deep dive just after. And one thing is very important with Twig is that the Twig environment provide all the method to extend the Twig environment with your own Twig environment or to use a dedicated object. That's why in the Twig environment, the tokenize method is a wrapper if you don't provide your custom lexer to the lexer provided by Twig library. Like I said, I speak just before on token. The lexer's primary responsibility is to transform the raw source PHP, the raw source code in Twig syntax into meaningful token. Just this. In fact, this action is called tokenization, and to go from the Twig template to the token stream just on the right, on the right, we just need to call the tokenize method. Okay, that's all. You just need to understand why it's exactly a token. It's not very important for this talk. But it's very important to understand because the lexer phase, tokenization phase, produce a token stream because the parser, the stage 2, need a token stream to enter in action. Here is the second line. On the previous line, we have Twig tokenize that will produce a token stream. Okay, we have some token. We don't know what is a token. It's not important for now. And when we are given the token stream to the parse method, we produce an AST node, abstract syntax tree. I not deep dive the abstract syntax tree here. It's not the aim of this talk, okay? But you produce something else, something other. Like for the tokenize method, the Twig environment provides the parse method, okay, which is a wrapper on the parser parse method. And if you want, you can provide your own parser. Here is what is the transformation from the token stream to AST. It's hard to represent an AST. It's a tree, it's a graph of different nodes. Okay, it's not so easy to produce this on the screen, so it's another representation. It's like a directory, subdirectory, and voilà. It's just for representation. It's not formal representation. So we have the token stream, and we convert it to something we called abstract syntax tree, which is composed with nodes, different nodes. Just one second, please. So we have the lexer, we produce the token stream, we give the token stream created through the lexer to the main parser, and the parser contains an iterator, a stream token iterator. It's very important to know that the parser will iterate on each token previously created and delegates the creation of the node on different parser type. With Twig, we have two types of parser. We have some semantics parser, if structure parser, if token parser, for token parser, block token parser, and so on. And we have expression parser. When you need to evaluate something, we have the functions, Twig functions, Twig filters, or operators, something like that. And everything can be we can add easily some dedicated parser through the token parser registry provided by the Twig environment. And the aim is really to produce an AST node. Okay? Donc, AST with nodes. Here is an example on how it's converted during the process. We have an easy template, okay, very simple example of Twig template. Second, when we call the Twig tokenize method, we have a token stream, which is represented on the second image. And after, we iterate on each token to produce an AST with dedicated node. So when you read the token stream, you can easily map what is going under the hood. We have the first token is block start, okay, it's the beginning of the Twig template. And after, we have token name if. And the parser detects that if need to be delegated to the if parser, and the if parser produce a dedicated node that will be compiled into PHP. That's the process. It's important just to understand what it's the chain, the pipeline of how Twig is compiling. After, we have a phase. It's not really a phase, it's a part of the parser phase, in fact, with Twig. But I think in other language or in other things, it can be a different component that will go in action to this. We have the semantic analysis phase. The semantic analysis phase is just a guard to check and verify that everything is okay during the parsing and during the lexing and parsing phase, tokenization and parsing phase. If you use some filter or function that does not exist in your Twig environment, you will throw a Twig error. You have a problem inside your Twig. Okay? I not deep dive each of these things. It's just for information. After we have the semantic analysis, we have an optimization phase. The optimization phase is very important because less nodes you have inside your IST, faster you will be compiled. The aim is to optimize the number of nodes. Okay? So actually, you can how Twig handles the optimization phase. It produces a node visitor through the visitor pattern to enter into each node of the IST and clean some code that will be cleanable. Okay? So the node visitor interface provided by Twig gives the capabilities to create dedicated visitor to handle this type of task. Here you have some optimization provided by Twig core. Constant expression folding. If you are writing something like that in Twig, it's not really necessary. So we can simplify this easily. We have expression simplification, such as this ternary. It's not useful. Node merging can be a little more complicated. Dead code elimination. We have loop optimization. I don't slide about it, but it's very interesting to deep dive into this subject. We have partial validation, we have IST catching, we have something like that. Donc optimization phase is very important. Yeah. And when we have everything clean and production ready, we can give the IST to a dedicated PHP class, which is a compiler. Something like that. We have the token stream. Token stream is given to the parse method, which is produce IST, which is composed by nodes, and the IST is given to the compiler to produce PHP file. Here is the logic under the compilation with Twig, but not only with Twig, the general concept. Okay. Like for the tokenization phase and for the parsing phase, you can provide a dedicated compiler if you want to override the compiler provided by Twig. Always from the Twig environment. Here is a more complicated example on why and how it's produced. It's not important to read the class, the template class on the right. That's not the aim. It's not very important. But when you are writing Twig code like that, in fact, after all the phase, we have a PHP file that will be displayed through the doDisplay method to your website, in your website or to your user. Okay? Something very interesting is a module node. The module node is the first node of the tree, of the IST. It's a root node. And in the context of the Twig architecture, the module node is the output of the parser phase and the input to the compiler phase. It's like a bridge. It's very important to know that. And we call, when this node is produced, a compile method is called on it, and this compile method called compile template, and you can see that methods are chaining to produce the PHP file. Okay? Under the hood, everything is like that. Just to have an overview and to have maybe a better understanding on how it's produced through the compiler, we have here a simple representation of an IST. And when we iterate on each token, or each node, sorry, we compile this node into something interpretable, into PHP. And when you see the compile method, you can see that you evaluate the node, you make some logic, and you are writing through the write method of the compiler, PHP, in fact, line by line. Okay? We have really a conversion. So, I hope everything is clear for now. So, just a deep dive with a practical example. And I think a picture is worth 1,000 words. Okay? So we need to add some grammar, some structure to Twig, and we need to create a switch statement into Twig. So now you have all the keys to create something like that into your project. Okay? You can create more Twig grammar structure instead of using function or filter or something like that. No. So we need to add a switch with case and with the default case. Okay? The first things to do is to write a parser. I don't deep dive into how we write this parser, but you need to create a dedicated parser for your new grammar that you will be add into Twig environment. Okay? We are writing the parser. After, we need to create some node. Okay? Each node is mapped to a language structure, a switch, and switch, case, or something like that. And we are converting the different things into the node into PHP. And we are writing switch statement, we are writing default, case, and so on. After that, we just need to register our new parser into the Twig environment. There are two methods to register your token, your new switch token parser. The first thing is if it's just a token parser, you can use the add token parser method on the Twig environment. And if your extension provides more things to Twig, such as function, such as a lot of parsing, new parsing things, a lot of structure or filters on whatever, test or whatever, you can use Twig add extension with your new extension, and you have a complete system with that. But in my case, I just want to add switch grammar structure, so I just need to add token parser on the Twig environment. After, I need to create some test. That's not unit test. That's not really a functional test or integration test. It's just a way to verify that my new parser is working fine. So for this, I can create a function like this. It can be a method or form an object, whatever. We are creating a dedicated loader, okay, with the array loader. You define a key as a template with a file get content on the Twig template. We instantiate a Twig environment, and after we add our token parser. And with that, you can load your key from the loader, and you can iterate and render the template and check if display is correct or not. Okay? It seems maybe complicated, but in fact, it's not so complicated to create something like that. It gives you really the power of enhanced Twig instead of create some hack or delegate it to PHP through function or filter. Okay, it can be a very good solution if you want to give to your team or your another developer, I don't know, more power and more knowledge on to produce templates. So my advice is very simple. There is no lot of resources about to know. There is a lot of resources on the internet, that's not the problem, but for me, just two links. You can read the documentation from Twig and dedicatedly the internals, which is very explained, better than me, I think. There is a lot of things very interesting inside this documentation, and you can read the depot, the repository from GitHub. Okay, that's my advice. If you want to enhance your Twig practice, just read that and have fun with this type of things. That's all. I don't know if you have some question. No question? Perfect. Thank you.